Flight added new dimensions to daily life. It changed perceived limits of time and space. Just a few decades after ingenious and intrepid pioneers of flight tried their luck with contraptions made of slats and sailcloth, engineers had mastered the art, applying complex technologies to build aircraft and rockets. But that was just the beginning. The conquest of the skies continues. French, American, Russian and British troops marched shoulder to shoulder through the Brandenburg Gate in Berlin in 1945 for the first and the last time. Historic events were also taking place in Potsdam. The trio of leaders known as the Big Three, Winston Churchill, Joseph Stalin and Harry S. Truman, sat down to redraw the map of Europe at the end of World War II. They put on a show of harmony for the camera. Germany is in ruins. Air and space research is prohibited. The German laboratory for aviation at Berlin-Adlershof is dismantled and carted off to the Soviet Union in pieces. Allied planes have sovereignty in German airspace. Liftoff after the war. Researchers prepare to launch A-4 rockets in the deserts of Arizona and New Mexico. The race to exploit German know-how begins. The top-secret US Special Mission V-2 ships 100 German missiles and 14 tons of documents. The archive from Peenemünde.
We in the United States and of course in Britain and France and the Soviet Union all inherited this wealth of new research that had been funded in the late 1930s and in the early 1940s in Germany.
The cornerstones of the spaceflight and rocket development programs of the coming decades are being laid, but not in Germany. It's become clear that countries seeking global power must have the latest technologies at their disposal. Among the technologies transferred as spoils of war are items like the Flettner Colibri helicopter. The German aircraft now sports a US star. Technical renovations, like automatically extensible slats, are incorporated in designs, including what is known as the Kruger nose. And aircraft such as the Mir 262 are being put through their paces on test ranges in Texas. German propulsion technologies also give the US a boost when it comes to developing their own new aircraft. The Russians are also launching their confiscated A-4s. In 1947, researchers prepared to send one up at Kapustin Yar. German knowledge is being applied to achieve Soviet aims, saving trouble, time and money.
We were faced with the question of where and how we could continue the work being done in Germany, because the Cold War had already started. So we were ordered to go out and catch German rocket specialists.
The Russians form what are called trophy brigades in Germany. Their job is to find and take with them test benches and entire production complexes.
We built the next rockets within a year, using our own material, even though half of what we needed we didn't even produce then. It was difficult to do everything the way the government wanted it. And that was, namely, just the way the Germans did, but without using a single German screw. In 1948, we launched the R-1 rocket, which was an exact copy of the V-2. But we built it of our own material.
The R-1 is modified, but based on German findings. A whole missile series follows, culminating in the R-5 in 1956, which is capable of carrying a nuclear warhead.
They took all the technologies with them. The Americans and the Russians took them, intensively developed them further, and channeled those developments into their own industrial assembly and development. That's something that gets lost. Most only think of the A4 rocket. But everything that was involved with those technologies was exploited intensively by both superpowers. In my opinion, you can't really put a number on it. The sum they saved on development costs would run into the billions.
Human reparation is a post-war novelty. The Allies call it a peace dividend. They place German scientists and engineers in their service, in some cases by force. In the US, Wernher von Braun is soon viewed as the most important POW from World War II. He and his team quickly come to dominate US missile research. In 1949, they test-fire a two-stage rocket based on the A4. It reaches an altitude of 400 kilometers.
It was almost from a standpoint of plunder in war, a unique moment in human history, because this was a case where science and technology was one of the greatest prizes that the Allied forces wanted to seize, after, obviously, the objective of winning the war militarily. And so there was a lot of improvisation going on as people were saying, we really got to take these people, we really need to grab this technology. And part of this was the upshot that the United States took a lot more German scientists and engineers than I think anyone had ever anticipated.
What was started at Peenemünde continues at Redstone Arsenal in Huntsville, Alabama. German scientists used the V-2 design to create the Redstone rocket, which is first used in the Korean War. A decade later, it is also used to put the first American astronaut, Alan Shepard, into space.
It had a lot of influence. Of course, when you look at the first large American nuclear missile, the Redstone, that was very much derived from the V-2. The first satellite vehicle, which is shown in this hall, is derived from the Redstone, which is derived from the V-2. So obviously there's a significant amount of influence there.
US troops sift through the ruins in Germany looking for documents pertaining to Nazi aerospace research. Engineers from Boeing are also along for the ride. They make a sensational discovery.
The American experts immediately recognized the significance of this document. And George Schirra wrote a letter to Seattle right away. You can still read it in the archive at Boeing. In short, what the letter says is, throw away everything you've done up to now. We found a new wing in Germany.
A letter by the man who has become Boeing's chief aerodynamic engineer, George Schirra. The newly discovered German innovations lead to fundamental changes being made to the design of the new Boeing B-47 bomber. A bit later, engineers in the US begin working on innovative turbojets. In October 1947, an F-86 with swept wings makes its maiden flight. It's a spectacular example of the benefits of utilizing the fruits of German research. Just 2 months later, the first Russian fighter jet with swept wings, the MiG-15, takes to the skies. In Paris in 1955, treaties were signed that ended the occupation of Western Germany. Nearly full sovereignty was returned to the country. Now the watchword is progress. The West moves on to new well-being and a new lease on life. Even Germany's airline Lufthansa is allowed to return to the skies after a decade on the ground. The old research institutes already had a 2-year head start. By 1953, they had reopened and started work. The 1950s are a time for experimentation. 1954 was also a watershed year for new developments in eastern Germany. A heavenly stage was being set for a sensational presentation and competition for hegemony. The Soviet Union had held Brunolf Baader captive. In the mid-1950s, he unveiled the 4-engine passenger jet, the Baader 152, in Dresden. But in the summer of 1959, the USSR refused to accept planes for use. The message was unmistakable. The development of civilian aircraft was to be terminated in Soviet-occupied Eastern Germany.
In the early 1960s, the German aviation industry moved into a new phase that lasted about a decade. They were working on an experimental aircraft that could take off vertically. Building an aeroplane that didn't need a runway to take off or land on had always been a vision.
April 1963 saw the debut of Germany's first vertical, short takeoff and landing aircraft, a fighter now known as the VJ-101. A high-wing aeroplane, the VJ-101's engines were located at its wingtips. They rotated from vertical to horizontal positions after the plane took off. The aim was to get into and out of the air almost independently of a runway.
But the vertical short takeoff and landing aircraft poses a particular problem when it takes off and still has no forward speed. It has to be stabilized, because the rudders don't work. They only start working at a certain airspeed, but the aircraft isn't moving. It's hanging in the air like a helicopter. So it has to be kept stable, controlled and trimmed by other means. Trimming systems were developed that later benefited aircraft in the 1970s and 80s. The fruits of vertical start aircraft development in Germany could later be seen in the Tornado and in the German know-how that was applied on the Airbus, and can still be seen in the control systems that we use in the Airbus today.
Dornier's Do-31 is the only steel transport plane in the world that takes off vertically. Europe also wants to make it into space on its own. In 1962, a multilateral decision is made to build the Europa rocket, and nearly all the aircraft and engine builders want in on the project. Germany gets the job of making the technologically demanding upper stage, known as Astris.
If I remember correctly, the first technical experiment started again in 1959, because they could use the old classic big test and proving ground at Traun again. It was a big, complex compound, and it's very interesting. It came through the war unscathed, without losing a single screw. Starting in 1959, DFVLR engineers and researchers came back to the compound for the first time. They started to build the first test bench and re-equip the facilities that would later be used intensively by ERNO, the North Development Circle in Bremen.
The aeronautical engineer Eugen Zenger becomes the head of the facility at Traun. A German spaceflight pioneer, he had already designed the supersonic Silverbird spaceplane in 1943. The planned Europa rocket proved to be a flop, primarily because the French, British and German-developed stages failed to work together. After 12 unsuccessful launches, the program was curtailed in 1973. After Germany regained control over its airspace in the 1950s, work began on the first rotary-wing aircraft. Test flights were carried out with new prototypes, but many of these designs remain incomplete. At the beginning of the 1960s, Dornier produces an unprecedented one-seater helicopter, but there's no market for small choppers. Meanwhile, several German firms, among them Borgward, are racing with one another to build the first practically applicable helicopter. New research complexes are built during that period. The DVL moves to Potsdam near Cologne in the late 1950s. Work also resumes in Braunschweig, in Göttingen, Oberpfaffenhofen and Stuttgart. In 1969, AVA, DFL and DVL merged to become the German Test and Research Institute for Aviation and Spaceflight, or DFVLR. The organization's aim is to make up for lost time by building on the successes that came in the decades before Nazi Germany's defeat. More than 2 decades after the closure of Peenemünde, Germany reset its sights on the stars. In 1969, Azur becomes the first German satellite to be put into orbit. The research probe is investigating the magnetosphere and the aurora borealis.
German policymakers declared in 1960 that they were not going to build and develop their own missile system. But they did say that they wanted to get involved in the satellite business. In 1962, Ludwig Bölkow wrote an exposé that called upon Germany to build its own satellite to show that it could do it. But what did that mean? Most of the components for satellites had to be obtained from the US. The Americans would also provide the rocket for the launch. That came to be known as the famous Azur project. Today it's known as the first national satellite, and it went down in history as the first project that intensively brought in industry, whether it was Dornier, Siemens or AEG, because they all supplied something. This marked the point of entry into the satellite business.
The success of Azur enables Germany to reach an ambitious partnership with the US. From 1974 onwards, Helios A and Helios B began studying the Sun. The twin solar probes were built in Germany, with the US taking responsibility for their launch. Both had an estimated life of 18 months, but continued sending data back from outer space for a decade.
1, 0.
A technological dream comes true when the first supersonic civilian carrier makes its maiden flight at speeds of Mach 2. The Concorde premieres in 1969 and is hailed as a flying masterpiece. Development of the distinctive delta-shaped wings can be credited to Dietrich Küchemann of Göttingen, Germany. And Karl Dutch, working in Braunschweig, laid the groundwork for the aircraft's control system. But the Concorde remains a luxury model. Only 16 of the supersonic planes are built. Another aircraft will soon become the pride of Europe. The A300 is the first plane the Europeans build jointly, with the aim of challenging US dominance in the civilian aircraft sector. The Airbus is going to be more modern and economical. German political leadership attends the unveiling ceremony in Hamburg in 1974. Bavarian State Premier Franz Josef Strauß and Hamburg Mayor Hans-Ulrich Klose are on hand. The redivision of the skies has begun.
By the mid-1960s, they had managed to sort out a plan to get a joint project up and running in Europe. Politics and industry closed ranks at the end of the 1960s. Germany, France, Spain and Britain all said they were ready to join in and gave the world the Airbus. The company Airbus Industries in Toulouse in 1970 and the first project, the A300.
In 1972, the A300 is the most modern civilian aircraft of its time. Nearly 600 of them are built. 4 countries are represented in the consortium that builds Airbus. The division of labour is done according to expertise. The British build the wings, Germany part of the fuselage and the tail, and the French the fuselage interior and the cockpit. Assembly is in Toulouse. From now on, the name Airbus comes to symbolise flying as an everyday activity. Germany hosts the 1972 Olympic Games. It's the first time that the competition is being broadcast via satellite. Together with France, Germany joins in Project Symphony and tries to achieve independence from the US when it comes to commercial communication satellites. But the failure of the Europa rocket means they have to seek US help to put their satellite into space, and the US refuses to use its rocket for commercial purposes. To increase their political influence in the club of countries that have mastered spaceflight, Western Europe's nations formed the European Space Agency ESA in 1975. Their task is to promote the scientific and technological interests of its member countries. The first German to venture into space comes from the eastern part of the divided country. On August 26, 1978, Zygmunt Jähn hurtles into space on a Russian Soyuz rocket. For 7 days, Jähn carries out experiments aboard the Russian space station Salyut 6. Using a new multi-spectral camera, the MKF-6, he photographs the Earth. The new device sets the global technological standard for space cameras. East German experiments and technologies are also carried into space aboard Soviet space probes. East Germany is pursuing a small but technically ambitious space program. The Airbus family is growing, and with it a whole new series of technologies. A new concept for steering a plane comes to fruition with the A310. Fly-by-wire systems and a fully electronic cockpit pave the way for planes guided only by a pilot and a co-pilot. In 1972, DFVLR gets its own test aircraft, the HFB-320 Hansajet. It becomes one of the most important research aircraft for aeronautical engineering and flight guidance. The Hansajet is used to test a revolutionary innovation in guidance technology. In 1973, an in-flight test of fly-by-wire is carried out to ensure it can be installed in new models of the Airbus.
The signals go through a computer instead of going directly from the pilot to the rudders. That means the computer can be programmed so that it first recognizes the aircraft's limits and then observes them. So the pilot can't make it fly too fast or too slow. The plane won't do it, it corrects itself. And the cockpits of all the Airbus aircraft can then be nearly identical, including the indicators and instrumentation. The changes are only stored in the brain of the computer. The computer knows I'm sitting in an A340 or an A320, and in future I'll be in an A380. Except for small differences, the pilot is always confronted with the same cockpit.
The A310 is not only the most highly developed aircraft of its time, it is also the first civilian airliner in the world to have supercritical carbon fiber wings designed for airspeeds just below the speed of sound. The wind tunnels at DFVLR are used to carry out airflow simulations on supercritical wings. Tests of air resistance serve to develop a new wing template for passenger planes flying at higher altitudes at speeds approaching the supersonic range. The competition hots up.
The Airbus A310 marks the first time that a civilian airliner was equipped with this profile in Europe. The USA initially objected when this became common knowledge, and there were fears of a lawsuit based on patent violations. But fortunately, it was possible to prove that a German patent had already been issued for the technology in 1943. So the American claim was moot. If that hadn't been the case, there could have been legal problems with the A310.
Europe creates a sensation by getting into space on its own. The failure of the Europa rocket notwithstanding, the Europeans worked together to make their own booster rocket, resulting in one of the most successful carriers of all time, the Ariane.
We had to see to it that we were standing on our own 2 feet and became as independent as possible from the Americans, who were our main partner at the time. But they also knew that they would only succeed if we had the most important part as well, our own payload-carrying rockets. By the 1970s, we were able to build satellites on our own, without help from the US. Having components delivered from the US was no longer necessary. But if you wanted to launch them, then you needed to put something on the launch pad in order to be completely independent.
The first Ariane departs on its maiden flight from its launch site in French Guiana on Christmas Eve 1979. Never before has a launch been so smooth. Ariane is also alone at the top when it comes to commercial success. In the 1980s and 1990s, the Ariane 4 cannot be beaten when it comes to launching the world's satellites. Germany also joins the US Space Shuttle program. For the Federal Republic, it's the start of manned spaceflight. The European Space Laboratory is conceived and developed in Germany. Spacelab is tailor-made to fit in the Space Shuttle's cargo bay. Under German leadership, Europe's space program has a stroke of genius. Even though it doesn't have its own rocket for manned spaceflight, European astronauts are still able to take part in routine missions in space. The arrangement is unprecedented, as is Spacelab's status as the most ambitious project to date in the history of space science. On German astronaut Ulf Merbold's first flight in 1983, he accompanies Spacelab into orbit. Based on weight alone, Spacelab is packed with more instruments than any other previously launched European satellite. Never before have so many experiments been run on a single mission. By decommissioning in 1998, 16 missions have been run. During its 181 space days, Spacelab gave 110 astronauts a base from which to carry out 720 experiments.
Spacelab could be described as Germany's dowry. The Americans profited from it immensely if you estimate the financing. For the first time, we supplied what was going to be carried in the cargo bay of the Space Shuttle. The lab was completely integrated in the cargo bay. That gave German scientists and researchers a place to run their experiments. And the configuration has continued to work until this day. It's on the International Space Station as well.
Germany runs the D1 and D2 missions. Zero gravity research is the name for the new space discipline being promoted by Germany's political leadership. Germany uses Spacelab intensively. For the first time, operations within the shuttle's cargo bay are not led by the US. Instead, mission control is at the German Aerospace Center at Oberpfaffenhofen. On the 7-day flight, Ernst Messerschmitt and Reinhard Fuhr carry out research together with their colleagues. They orbit the Earth 110 times. The data gathered provides researchers enough material for years of exciting work. 75 experiments were carried into orbit on board D1. Among them were probes of the effect of zero gravity on biological and medical processes. In 1993, Hans Schlegel and Ulrich Walter take off on the D2 mission. The Europeanization of aeronautics research is also progressing. In 1980, the German-Dutch wind tunnel begins operation. Along with it, Germany takes a step closer to the pinnacle of global aviation research. Airflow tests are carried out on a model of the Airbus A340. Airbus planes have become serious competitors for those produced by the American aviation giant Boeing. Germany sets its course for the future of air transportation with the addition of the VFW 614 ATAS to its research fleet. Starting in 1986, the new aircraft gives German aviation research the first flying simulator. The plane allows researchers to gain insights that cannot be obtained by computer simulation. With the ATAS, the behavior of new plane designs can actually be simulated in flight. Carbon fiber construction technology ushers in a new age for aviation and a technological leap in international aircraft manufacturing.
This design has enormous advantages. The surfaces are much smoother than they would be if they were made of wood or metal. Above all, you can create shapes that are significantly more aerodynamic. Airbus started using carbon fiber instead of fiberglass with smaller surfaces, control system surfaces, spoilers, and then complete tail units. They had to use carbon fiber because of the need for stiffness. Airbus was a pioneer in this area. Airbus was the first company that made tail units completely out of carbon composites.
On November 9, 1989, the Berlin Wall comes down. German reunification brings with it the dawn of a new era for German air and space research. DFVLR becomes DLR. Times are also changing in space policy elsewhere, leading to intensive use of the Russian space station Mir by Western European astronauts. In 1992, Klaus-Dietrich Flade, a test pilot from the German Armed Forces, the Bundeswehr, goes into space as a research cosmonaut on a mission to Mir. Ulf Merbold follows in 1994. At this time, Germany in particular is able to profit from decades of close East German contact with Moscow. In 1995, Thomas Reiter goes on a space mission from a united Germany. He spends 179 days aboard Mir. It's the longest time a non-Russian cosmonaut has spent in space. Preparations for setting up the International Space Station, the ISS, are beginning. Reinhold Ewald also works aboard Mir in 1997. Together with Russian colleagues, he returns from space to land in the snows of the Kazakh steppes. A corporate jet, the Falcon 20E, that belongs to the German Center for Aerospace Research, DLR, has been used for more than 3 decades to investigate aircraft emissions. The Falcon flies in the exhaust of a large passenger airline. Today, DLR has the largest fleet of research aircraft and helicopters in Europe. Research is also taking place to make planes quieter, by minimizing the amount of noise aircraft engines make. A noise testing is carried out by DLR in cooperation with Lufthansa. New noise-reducing engine technologies and designs aimed at reducing noise from airstreams should make planes quieter. By the 1970s, growth rates for air traffic were already between 6 and 10%, and the volumes being transported have doubled every 10 years. As a result, economy has long since become one of the most important criteria for aviation. At DLR's tower simulator, new technologies are developed and tested that are aimed at reducing the unfavorable aspects of increases in air traffic. By simulating traffic patterns in German airspace, bottlenecks can be detected early on and avoided. The most complex environmental research satellite of all times is being built at EADS, Astrium in Friedrichshafen. Envisat can multitask with the best of them and is the pride of German engineering. Since 2002, Envisat has been analyzing developments above the polar regions, oceans and continents. On board is a German-Dutch instrument, Skiamaki, which can precisely detect trace gases in different layers of the atmosphere. That makes Envisat one of the most indispensable aids for monitoring compliance with the Kyoto Protocol and for crisis management. Data from space are often the sole sources of comprehensive information on local conditions after severe storms, floods or earthquakes. In 2000, German astronaut Gerhard Thiele joined the SRTM mission, the task of which was to produce a precise 3D map of the world. The German space technology sites are set further afield. In 1997, the Cassini-Huygens space probe was a joint European-US mission to Saturn and one of its moons, Titan.
And liftoff of the Cassini spacecraft on a billion
It reached striking distance of Saturn in 2004. German scientists are also exploring the planets Venus, Mars and Jupiter.
The fruits of research done at German institutes can be found everywhere. Whether it's the Titan, or the landing of Huygens, or Cassini. Think about the Mars Express. That means we have very good linkage between research and industry. You have to remember to keep watering this plant conscientiously, because today we're in a position to be completely independent when it comes to spaceflight. We don't need to rely on help from anyone today. We can handle big projects by ourselves, thanks to the developments that began in the mid-1970s. We don't have anything to be ashamed of.
In the summer of 2003, Europe's first independent mission to another planet, the Mars Express, is launched. On board is a unique high-resolution stereo camera. Built at DLR, it enables the camera to create high-resolution images of planetary surfaces in color and 3D. The results have a much broader audience than planetary researchers. After 45 years of the closest cooperation in spaceflight, Europe is now on equal footing with the US and Russia. It is autonomous without insisting on autarky. After France, Germany is the second most important partner in building the Ariane 5. German engineers test the engines and design, develop and build the upper stage.
All space flight today is the legacy of German pioneers and the result of achievements made in Germany. Even now, Germany is developing technologies that are unique. After all, at ESA we have to know, because we publish pictures of Mars on the internet daily. These images come from an extremely precise, three-dimensional camera that was developed and built in Berlin. Rosetta is a small lander that's going to touch down on a comet in a number of years. It was also designed and developed in Germany. So the tradition is being kept alive, even when other countries contribute to the technological advances that are being made today.
2, 1, top. Allumage Vulcain. Paramètres bord correct.
The sky's still the limit. With Europe's global satellite navigation system Galileo, the aim is to provide the world with reliable positioning information. A civilian project, the 30 planned Galileo satellites promise to be more reliable for users on the ground than the US or Russian systems. Through its many applications, whether it's in heavy traffic or the remotest of areas, the Galileo system demonstrates the immediate benefits of spaceflight for daily life on Earth. Since 1984, a number of countries have been pursuing the aim of operating an international space station. The end of the Cold War paved the way for the ISS project becoming reality. One of the greatest technological ventures in human history, it not only serves research, but promotes understanding between peoples. In 2006, Thomas Reiter became the first German astronaut to work aboard the ISS and outside the spacecraft. During the first long-term European mission on the ISS, Reiter carried out 33 European experiments. He's also the most experienced astronaut in the ESA crew.
The ISS is undoubtedly a moment in technological development that will last beyond this period. I see the point of this station less in a purely scientific sense than as a station that links political systems to one another. It's a station that led to international cooperation between East and West. And as a political symbol, it has already achieved a great deal.
A German-led team built the research laboratory Columbus as a successor to Spacelab. The new project also comprised Europe's contribution to the International Space Station. Mission control is based at the German Spaceflight Control Center at Oberpfaffenhofen.
Without teamwork, nothing can be achieved in spaceflight. Every engineer, every scientist, and every technician has a place on the team. An astronaut can only be in orbit because on the ground, hundreds of people are there who have trained him and who make it possible to monitor what's happening on the space station.
Entraîner cet astronaute qui permettent de surveiller ce qui se passe à bord de la station spatiale.
Without every single one of those engineers, technicians, and scientists, an astronaut is unable to do his job. Spaceflight operations intrinsically involve technical risk. They demand teamwork, and through this teamwork, everyone plays a key role.
Et ce travail d'équipe fait que chacun a une place essentielle.
Germany's position in there is very strong and frankly limited only by the German government's willingness to put resources into the enterprise. Let me say, Germany, of course, built the Columbus module, which next year, in 08, it's almost 07, in 08 will be flown up to the space station, and it will augment the research capability on the space station today by fully 50%. So, I mean, that's a tremendous accomplishment. In the early shuttle era, Germany was involved in the building of the Space Lab modules, D1 and D2. Looking to the future, of course, Germany is part of the European Space Agency, which has now for a long time been a partner in the U.S. manned spaceflight program. I hope that will continue.
Built in Bremen, the Columbus Lab has space on board for 4 astronauts to carry out research. Commissioned by scientists on Earth, they will carry out long-term experiments in zero-gravity conditions. German astronaut Hans Schlegel will accompany the Columbus laboratory to the ISS. And one of the world's largest aircraft, the A380, is being cleared for takeoff. The largest passenger carrier on the globe is being readied for mass production. Aero-elasticity tests are being carried out under the guidance of the DLR. It's a test that every newly developed aircraft has to be subjected to.
Basic research is what we build on in industry. DLR's primary function is to work together with scientific institutes and colleges and so forth, who we then cooperate with in many diverse ways. We use their achievements and basic findings in applied research and incorporate them in technological developments. Without the work they do to begin with, we could never make our innovations a reality.
Germany is one of the world's leaders in the development of oscillation technologies used to test flutter in aircraft. The A380 is the pride of the Europeans and a prestige project, a new star in the skies, the most highly developed aircraft at the outset of the 21st century. Awe at the miracle of aviation is by no means a thing of the past. Since the infancy of motorized flights more than a century ago, taking to the skies has lost none of its fascination. German engineers and scientists have left their mark on technical and scientific progress in many disciplines. And air and space research continue to reflect the daring to make discoveries and eternal curiosity. The conquest of the skies continues.